today's presentation, we will start with an overview, a plan for what will be presented. Cable stay bridges are a very popular bridge that are used to span valleys and bodies of water. These bridges have been around very long and have advanced over time. The primary difference in modern cable stay bridges is the materials used and the orientation of the cables. The pylons can vary in height depending on the length it needs to span. This is the cross-section of a typical bridge deck. In this picture, the girders are depicted as I-beams on either end. The cables of the bridge are fastened directly to the girders to support the roadway. The floor beams help to stabilize the girders and keep them a set distance apart. The deck surface lays across the framework, which is made of girders and floor beams. The decking is commonly pre-made into segments so that the bridge can be assembled on-site with minimal effort. This allows for efficient building and repairs. Cables are the fundamental component of cable stay bridges and support the dead load of the deck as well as any additional mass. These cables are in constant tension due to the downward weight of the dead load and must sustain static equilibrium of the structure. The force from the weight of the deck is carried through the attached cables and transfers the load to the pylons. The cables are commonly arranged in three different orientations as displayed. The harp shape is shown on top, followed by the fan arrangement, and lastly the semi-fan arrangement. Through the use of computer-generated testing methods, it is prevalent that the semi-fan arrangement will result in the lowest tensile forces acting on each cable, as well as most uniform distribution of the cable forces throughout each bridge. Another design variable that can affect the capability of the cables is the pattern in which the cables are constructed. There are many different arrangements of the strands in cable construction, but the most common for cable stay bridges are the helically wound strands, parallel strands, and locked coil strands as displayed. Each type of cable has different characteristics, but the focus is on their tensile strength and Young's modulus of elasticity. Through the use of material testing methods, results have shown that parallel strand cables can endure the highest ultimate tensile stress and has the highest Young's modulus. The choice is clear. Parallel strand cables will be able to withstand the largest applied tensile force and would provide the stiffest erect cables. The pylons are a crucial part of any bridge. Compared to other bridges, cable-stayed bridge pylons hold the entirety of the bridge weight. Essentially, the two parts of the bridge that the pylon supports on either side balance each other out to make the moment around the pylon equal to zero. The weight of the bridge translates to the compressive forces in the pylon. Additionally, as the height of the pylon increases, the compressive force decreases because it is spaced out throughout the pylon. The pylon is then supported by the foundation. Pictured here, you can see three different types of bridge foundations. The three types are the raft foundation, piled foundation, and piled raft foundation. Raft foundations are used in environments that have a strong natural base, such as stone or bedrock. These are the simplest type of foundation because they require minimal materials and are essentially just a reinforced slab of concrete. The other two types include piles driven deep into the ground to support the base of the bridge pylon. The piled foundation is used in very soft soils, such as sand or mud, and has piles supporting the entire base of the pylon. The piled raft foundation is clearly used for those applications where a raft foundation isn't sufficient, nor is an entire piled foundation necessary. The main goal is to make a stable base so that the civil engineer can assume the base is fixed when he is designing the bridge. There are many variables that go into building a bridge, depending on the circumstance and parameters the bridge needs to fulfill. The cables can vary in material and orientation of the specific strands, the pylons can vary in height and amount, and the deck can vary in its dimensions. Due to their versatility, cable stay bridges are widely used around the world.